Okay, hello everyone. I am making a video of the solution to our homework. Okay, for this question, we started with 4C. Okay, this is how the tree diagram looks like for this question. Okay, take a moment to understand it. It's pretty straightforward. So the question asks for expected number. If you recall, expected number is the probability of whatever they're expecting times the sample size. In this case, the sample size is 2000. They are asking for expected number of failures. Okay, so find what is the probability of failures. Now, this probability experiment is a combined experiment. Okay, so when it is a combined experiment, the probability, you have to look at it from a combined point of view. So the probability of fail comes from C and fail and D and fail. Okay, so there are two possibilities, and these two possibilities cannot happen at the same time. Okay, and they are mutually exclusive, so we add them. Okay, the probability of C and fail, if you look at the branches, is 0.7 times 0.1, and the probability of D and fail, if you look at the branches, it's 0.3 times 0.05. And because they are mutually exclusive, you add them. Key this in your calculator, you get 170. So out of 2000 strawberries, we are expecting 170 of them to fail the QCI. Okay, this 170 is just an expected number, what we expect. It may not happen in reality. It may be less or it may be more. Okay, the key thing here is the probability of fail comes from combined events. So C and F, D and F. Alright. Okay, the next question. They said they want the probability of pass to be 0.93. And the probability of pass comes from C and pass and D and pass. Okay, always remember this is a combined event, so look at the combined outcomes. Alright, and they want us to figure out what is the percentage of strawberries that should be supplied by D. Okay, in the beginning, the question says that 70% came from C and 30% came from D. Now, they want to change that. They are asking what should be the percentage from D is such that the probability of pass is 0.93. So, we have to discard the 0.3 and 0.7. We have to find out the new number. Okay, and this is where algebra comes in. So, we use X for the D and 1 minus X for C. Why 1 minus X? Remember, every branching adds up to give you 1 because total probability is always 1. That's why for C is 1 minus X. Okay, so the probability of pass came from C and pass, so 1 minus X, and also comes from D and pass. So what do I do to them? For each green circle, I times them. So the first one is 0.9 times 1 minus X. The next circle is 0.95 times X. So I add them, and that should give me 0.93. Even though this is probability, when there is an opportunity to use algebra, use it. So this is a simple algebra. Okay, it should come to mind that we should expand. Okay, be careful of negative and everything. And your answer should be 0.6. So what this means is the probability that it comes from D is 0.6, but the question asks for percentage, so I just times 100. So 60% should come from D. Okay, now what was the challenge? I think it's because last year when we did probability, there was never any algebra involved. Okay, but you should know the algebra is at the heart of every mathematics topics. So when there is a need to use algebra, use it. And whenever you use algebra, there will be an equation and you have to solve it. Alright? Okay, the next question. Okay, this is pretty hard. Let's approach this using the Venn diagram first. So the story is involve two things, a blue car and 5 doors. Okay. The probability that the car is 0.5. My question is, should I write 0.5 there? Does that region represents the probability that the car is blue? Now think. There is a keyword in a probability question that we have to always look out for. And that keyword is only. This region, okay, this region is only for blue only. But the question says blue. So, it is not here. In fact, 0.5 it's, okay, like I said, this region only represents the car is blue only. But if the car is blue without the word only, then it represents this green region. Okay, the keyword here is only, and therefore the probability that the car has 5 doors is 0.3. If you follow the same logic, it should be this blue region. Okay, the statement isn't the probability that the car has 5 doors only. Okay, the word only is missing. Okay, so we can't fill anything in the Venn diagram because we can't fit the numbers into the regions. So let us look at the next information. The probability that the car is blue or has 5 doors. Okay, the keyword here is or, and you should know or is always related to union. Okay, now recall how do we approach this. Okay, kalau or related to union, so probability of blue union 5 doors is always probability of blue plus probability of 5 doors, and there's something else minus the intersection, and this should equals to 0.6. The probability of blue we know 0.5, the probability of 5 doors is 0.3, but the intersection we do not know. And we can solve this. The answer is just 0.2. And where is the intersection? It is this region. Now that I know this region, this intersection is 0.2, I can find the blue, which is just 0.5 minus 0.2. And I can find the region with 5 doors only, 0.3 minus 0.2. And the outside region, we should know that, you should know that probability when you add up should give you 1. So the outside region is just 1 whole minus 0.3 minus 0.2 minus 0.1, and you should get 0.4. Okay, that is how you fill up the Venn diagram. So let's answer the question. The probability is not a blue car with 5 doors. Okay, we shall go with this interpretation. If it is wrong, okay, I will update you later. So blue with 5 doors is simply blue intersect 5 doors. Okay, because I want blue and I want 5 doors. The word and is always intersection. If I want the not, it just means is the prime, the complement. And this complement is represented by the blue region. All the region except the intersection. Okay, so if you look at all the numbers in the blue region, okay, it's just 0.3 plus 0.1 plus 0.4, and I get 0.8. So the answer is 0.8. Okay, now the next part. Okay, before that, what to look out for? Okay, I've been mentioning it. I have been mentioning this quite many times. Look out for the word only. Okay, only you. Okay, let's go. Now let's use the tree diagram. The tree diagram. Okay, now in this case, it's a combined event. We are interested in the color of the car, and we are interested whether it has 5 doors or not. Okay, so we put as color of car and number of 5 doors, and the car can be blue or not blue, and the number of doors 5 doors or not 5 doors. Okay, so this is how your tree diagram should look like. Okay, let's fill up some numbers. Okay, the probability that the car is blue is 0.5. That one we can put here because that is the probability that it is blue. Okay. So if the probability it is blue is 0.5, then the probability that it is not blue is just 1 minus 0.5. Okay, remember in every branch the probability add up to give you 1. Okay, next thing. The probability that the car has 5 doors is 0.3. Okay, here's a bit tricky. Does this mean these two lines I can write 0.3? Okay, I'm sorry, there's a mistake here. The green numbers should be 0.3, okay, not 0.5. Okay, let me make the correction here. Okay, 0.3. Okay, so does it mean it should be 0.3? No, because each of those line is a conditional probability. The top line, okay, the branch at the top, it represents probability of 5 doors given the color of the car is blue. The below branch is the probability that it has 5 doors given that the color is not blue. So conditional probability is not the same as the probability that the car has 5 doors. In fact, the probability that the car has 5 doors is actually these two combined region. Okay? Always remember, it's a combined event. So the probability of 5 doors comes from blue and 5 doors and not blue and 5 doors. Okay? And this is a conditional probability that I mentioned just now. Okay. So what can we do? We can't seem to fill any numbers for the remaining branches. Let's look at the remaining information. The probability that the car is blue or has 5 doors. Okay? Just now we already interpreted this. It's just probability of blue plus probability of 5 doors minus probability of blue and 5 doors equals 0.6. Okay? We know the numbers 0.5, 0.3. Intersection we do not know. And the intersection is simply 0.2. So, where is this blue and 5 doors represented in the tree diagram? Okay, blue and 5 doors, where is it represented? If you think carefully, it is this region. This is blue and 5 doors. So this region is 0.2. Okay? Now, the question says not a blue car with 5 doors. Okay? Now, blue car and 5 doors is this. Blue intersect 5 doors. If I want the not, it's just the intersection. It's just the complement, the prime, sorry. Okay? So, if the probability that is blue and 5 doors is 0.8, is 0.2, then the complement is just 1 minus 0.2, 0.8. Because a set plus its complement is always equals to 1 if you calculate the probability. Okay. I hope this is clear. Alright.